Hey, Algebra 1 students, this is Mrs. Anspaugh. I'm back to teach you about multiplying with scientific notation. In the first video, I showed you how to take a number, a very large number or a very small number, and write it in scientific notation. And vice versa, we also took the scientific notation and wrote it in standard form. Here I would like to show you how to actually multiply using scientific notation. For instance, if I gave you 2.1 times 10 to the 8th, times the quantity 1.5 times 10 to the 6th, I would like to show you how to multiply this without using a calculator. So the first thing we're going to do is remove the parentheses because they're unnecessary here, knowing that it's a multiplication problem. The second thing we're going to do is collect the 2.1 and the 1.5. So we're going to rearrange those so that they're listed first. And then we're going to put our powers in the end at 10 to the 8th and 10 to the 6th. So in doing that, we're actually multiplying 2.1 times 1.5, and that's going to give us a value of 3.15. And then we know the rule that says if you have the same base, you can just add the exponents. And so quickly, without using a calculator, I can rewrite this multiplication problem as 3.15 times 10 to the 14th power. And again, we know it's in scientific notation because this number is in between 1 and 10. And that's your final answer. So let's take a look at another one. 5.63 times 10 to the 7th multiplied by 3.4 times 10 to the 8th. Again, we want to collect our terms 5.63 and 3.14. Again, it's like the commutative property of multiplication. And then again, we're going to pair together our powers 10 to the 7th times 10 to the 8th. So if we multiply 5.63 times 3.4, we end up with 19.14 times 10 to the 7 plus 8. Again, we have the same basis, so we add the exponents. However, if you notice, 19.142 is not between 1 and 10, or less than 10, I should say. So that tells me that I need to move my decimal over one place to the left to make this 1.9142. And with doing that, it's going to adjust my exponent. So I'm moving my decimal over one place to the left. So I need to adjust my exponent by creating this 15 into a larger number. So if I move this decimal over one place to the left, I'm making the 15 one more larger, which means I moved it basically 16 places. So my new answer is 1.9142 times 10 to the 16th. So let's try a few on our own. Pause the video, take some time to multiply out these products and see what you get. And then we will come back and reveal the answers. Number 1, if we multiply 8 times 1.2, we end up with 9.6. And again, we just add the exponents because we have the same base, so it's 10 to the 25th power. And again, I don't have to do any adjusting because my answer is just between 1 and 10, or my A value is between 1 and 10. Number 2, we're going to multiply 2.4 times 4.9. We can add our exponents. So we end up with 11.76 times 10 to the 16th. And here is a scenario that we have to adjust our exponent because we're not in between 1 and 10. So I'm going to move my decimal over one place to the left, which tells me I'm going to make my exponent larger. So I have 1.176 times 10 to the 17th power. Number 3, multiply 3.7 times 6.5. That gives me 24.05. Times 10 to the 8 plus 10 is 18th power. Once again, we have to adjust our decimal here so that we can create a number between 1 and 10. And so this means if I move my decimal over one place to the left, I have to increase my exponent. So instead of 18, it's going to be 19. And there is my final answer. And last but not least, same thing, 9.7 times 8.6. However, notice our exponents are negative, so careful when you're adding your exponents. We know the rule says two of the same signs, you add them, and keep the same sign. So we end up with 83.42. Again, we have to adjust our value here so that it's in between 1 and 10. But notice if we move our decimal one place to the left, we're making our number smaller. When you make a negative larger, it actually becomes negative 10. So be careful there. We're still moving our decimal to make this number smaller, and we're creating our exponent so it's larger, which becomes negative 10. And that concludes our mini lesson on scientific notation. Peace out, dudes.